Hello, welcome everyone. This is Mesut, and I'm very happy to be a part of this lovely conference, Scottish Summit 2021 virtual edition. Of course, we are still not able to meet in person, but at least this is still a great opportunity to meet online. And in the session, we will discuss four pillars for successfully conducting an agile test automation project. Of course, for test automation, we can talk about a huge number of golden rules or principles, but for this session, I tried to wrap them up under four fundamentals, and we will discuss them one by one in detail. Before starting, let me briefly introduce myself. My name is Mesut, and I'm from Turkey. I'm a QA engineer with more than 12 years experience, and currently I'm located in Tokyo, Japan. I'm working for Rapid Robotics, and in the robotics domain, I'm implementing some test cases, automating them, and integrating them into pipelines to be able to trigger them over the jobs or schedule them for the nightly jobs or frequent executions. And you can find me on Twitter or LinkedIn, so just feel free to be connected. And finally, a big shout out for the organizers and the sponsors of the event to help this amazing conference happen. This is the brief agenda for the talk. As I told, we will go over four principles, four fundamental principles one by one in detail, and we will start with the quality mindset, which is closely related to the customer perspective and to be on the correct goal every time. And then we will discuss monitoring activities and the importance of various metrics and to make all the progress and the aspects of the product visible. And then we will discuss the robustness in our automation framework. This is very important in terms of the stability of the executions, because if we have some test smells or if we have some weaknesses in the test code, then we will face some issues and we will have some unstable executions and some not real bugs, but some false alarms in the failures. And we will have to deal with them to analyze and maintain them and lose too much time. And finally, we will discuss the team spirit and how we can maintain a good collaboration and cooperation in the team. Continuous improvement is needed to achieve our goals, because otherwise, if we do not take care of these best practices, then there will be some consequences in terms of different perspectives. On the one hand, of course, the technical debt will increase in time. And on the other hand, there will be some projections of these technical problems into some personal issues. I mean, people will lose their motivation and concentration in time if it is seen that we are not making a good progress on our goals, or we are not achieving our goals. Then people will lose their faith, and it will be very difficult to be on the same page for everyone. So these best practices do not have a great importance only in terms of the technical aspects, but also in terms of the team spirit as well. So let's start with discussing these four pillars one by one in detail. And the first one is the quality mindset. Sometimes we have a very limited time to verify and validate the features or the existing aspects of the product, and especially just before going production environment, because we develop some new features and new functionalities into the product, and they have to be verified. And if there are some vulnerabilities or weaknesses in the product or features, then the release is blocked. Or otherwise, if there is no problem about them, then we let them go to production environment. So it sounds a little bit risky and stressful, because if any bugs are overlooked, then they can go to the production environment and they can be encountered by the customers or the end users. So, otherwise, if we find any bugs or vulnerabilities, then after a long and tiring sprint and after long working days, it can be disappointing for the developers or the product owners to block the release. So we should have the courage to take the correct action, either to block the release or to let them go into production environment. So it is stressful and kind of responsibility, but even under stress and under pressure, the thing is we have to protect our quality mindset. I mean, when everyone is looking into your eyes to wait your approval, then if we tend to quickly check all the test cases, all the results of individual test cases, and quickly tend to pass them, then we may overlook some bugs or vulnerabilities in the product. It is very likely to miss some of them if we tend to quickly check everything and without investigating them in detail. So the protecting the quality mindset, even under stress time and even under pressure, is of great importance to keep the quality of the product in high standards. And moreover, in addition to the quality mindset, looking from the customer's eyes is very important, because if we miss some bugs, they will go to the production environment, and if they are not caught in time, but they are caught in later stages, maybe in the production environment, then it means it will be a prestige issue for our company, for our product, for our brand, everything. Because normally it is not a desired situation. We do not want customers or end users to find some bugs in production environment. And it means additional cost, because if we find the bugs in time, then it is much more easier, or it is not expensive to fix them in time. But after everything about the development is done, is performed, then it is much more difficult to apply our fixes, because we could not find them in time, and now it is very difficult to apply our fixes. So escape bugs, which are the bugs which are not found in development activities or testing activities, but found in the production environments, are the situations that we should avoid in the best way. But how can we minimize the escape bugs? Of course, at this moment, test coverage is very important, because if we are not covering all the features or all the functionalities of the product in a proper way, then it is very likely to miss some of the weaknesses of the product in different aspects. For example, let me give an example. If we are testing a data upload feature, then testing the functionality with a limited data type or some limited data values is not sufficient. For example, for the data upload feature, if we are testing with integer values, even if we observe that the functionality is working properly for integer values, we cannot be still sure about if it will work again properly for string values or some other data types. So testing with only a limited data inputs is not sufficient, and we should cover all the possible data types and data values, including the boundary values, the corner cases, positive values, negative values, lots of things. And in this way, we should increase the test coverage, not to miss any bugs that can likely to occur in different conditions. And additionally, looking from customers' eyes is very important, because before going production, we will be using the features and the product lots of times. We will be already experts using this product, but it is not the case for the customers or the end users. Most probably it will be the first time for them to use this product. So they will not be experts like us, and we should think about how easily they will be able to use this product. We should think about the usability of the product itself. So maybe if it is not very usable, and the usability of the product is not in a good situation, then maybe the customers will fail to use it. So we will not lose the customers, and we want customers to easily use this product. So we should think about all the aspects of the product in terms of the quality, not only functionality, but the performance of the product, the usability of it, the availability of all interfaces, and all the aspects of the quality. And secondly, after the quality mindset, we will discuss a little bit about the monitoring activities. The monitoring activities enable us to see our current evaluation, to see our current situation, and to make a future estimation as well by doing a projection in terms of the current values to predict some future actions and future situation. I will illustrate this issue with a real-life scenario. For example, when we are driving, when we are using our vehicles, cars, we have lots of monitoring panels in front of us. This is why the vehicles, the cars have lots of monitoring panels in front of the driver, because we want to see lots of metrics. Maybe we want to see our current speed, the average speed, the current oil consumption, the level of gas in the tank, lots of metrics we can track and we may want to see, because otherwise we cannot take control of the car. Otherwise, we may fall into some undesired situation. For example, if we do not continuously track the level of the gas in the tank, then maybe we can immediately run out of gas, because until that time we did not track it. Otherwise, if we track that, then we would already see that it is going down. And then we would have the chance to take the needed action item to fix the issue, or apply the fix to improve the situation. So it works in a very similar fashion for our projects. For example, we can track lots of metrics, and if there is a not going situation, or if there is a situation which is not going well, then we can easily see it in time in terms of the monitoring activities. Because otherwise, if we do not continuously track, then we would not be aware of this fact, and we may miss some action items that had to be done or had to be performed in time. So there are lots of metrics that we can continuously track and monitor, but what kind of metrics that we can make use of? What kind of metrics are useful for us to see our current estimation? Let's consider various metrics related to time, cost, scope, or progress, or lots of different aspects. So there are maybe a plenty of hundreds of metrics that we can continuously track or monitor. But of course, trying to cover all of them maybe does not make sense, because we would not be able to achieve covering all of them. Then maybe what we can do is to decide a subset of the metrics to go with, and select some of them and be selective to decide the best metrics that will serve to our goals in the best way. So we may have some criteria to select some different metrics, because first of all, we should know what our goal is. I mean, if my goal is to reduce the average execution duration, then maybe mostly I should concentrate on the time related metrics, or the execution duration related metrics, because my goal is to decrease the average execution duration. For example, that was the case in my project, because we were continuously executing test cases, and we had limited time, and we did not want downtime to decrease the availability of the system. So this is what we wanted to do. We wanted to decrease the average test execution durations, to decrease the testing windows, to avoid the downtimes. So what we continuously track is the average execution duration for each individual test case, and in this way we achieved goal by applying some fixes. And after applying some fixes, then we should again monitor the same metrics and see the effect of the application, if it worked or not. If it is not helpful, then we may skip that application and try another one. So we can, in this way, we can go over lots of different trials, and each time we have to see if it worked or if it contributed in the solution or not. So at this moment, we have to be selective to decide on the best subset which serves to our goals in the best way. And of course, after deciding all the metrics, we should make our environment visible, because we have to monitor each aspect or each different perspectives of our process. So in order to be able to do this, our environment should be visible or transparent to be monitored, because otherwise we cannot see, even if we have the monitoring activities, if the environment or the products are not available, then we cannot pull or collect or parse the relevant metrics or the relevant values from them. So what we have to do is to increase the transparency of different aspects of the processes or the products or the platforms that we use. For example, in our project, we were using Jira as the issue trackment system. And if we want to see all the status transitions for a test case, for example, or for an ordinary different issue, then we have to be able to see all the state transitions. For this purpose, we add lots of custom status in the platform. For example, for our test case, it starts with the design of the test case, the definition of the test steps, and then after it's designed, it goes under review. It is reviewed by another colleague in the team, and after it is reviewed, and if everyone understands the same context from the test case or test steps, then it means that the test is executable if there is no any other impediment to execute it. And at least it can be executed manually. And afterwards, we start with the automation of the test case, and we proceed with the automation steps. And after the code is implemented, then we send the code to review again. And after the code is reviewed, then it is merged into our pipelines. So this is the whole life cycle for the test cases. And since we already implemented all these status in the Jira in our issue management and track system, we are able to see all these transitions online, and we can see how long we wasted time, how much time we wasted on each status. For example, how much time do we need for the implementation of the code? I know this average value for each test case because when I pull the queries from the Jira, I can see that on what time the implementation started and on what time it went from implementation to code review. Since I can parse all these metrics, I can collect some insights from our processes or related to our processes or the products as well. And of course, trying to do all these activities manually is not easy because if we regard that I want to do this as a daily activity, preparing the queries and sending them to or performing them on the user interfaces is not easy. Each time I have to analyze the results, I have to parse the related field of the response, so it is not easy. So what we can do is to perform these activities automatically by means of some automation code. And most of the products have some open APIs supporting these kind of automation stuff. I mean, for example, for Jira, there are some open APIs, and for some other platforms, there are some open application interfaces. So we can send some queries automatically over the code and collect the response again automatically. And for the response, we can parse the related field that we want to focus on. And after parsing the related fields, we can make our interpretations or analysis on these fields. For example, on this example, we can see a piece of code which sends a query to Jira and collects the response. And from the response, we can, over the issues, we can parse the creation of the issue and resolution of the issue. And if I subtract one from the other one, then I can reach to the resolution duration, right? Because I know the creation time, I know the resolution time. Then the resolution duration is or can be calculated with this code. And similarly, we can collect lots of different insights as well. And we can make use of these monitoring activities to reach to some interpretations about the processes, the health of the processes, or the health of the product in the meantime. The numbers are great. The numbers are telling some stories to us, but of course it is not easy to make these interpretations or to understand or to get some insights. But instead, if we somehow visualize them, I mean, if we somehow transform these numbers or metrics to some monitoring graphs or to some monitoring dashboards, then it is much more easier to understand what's going on in our environments. I mean, we can immediately see if the trends are going high or lower, if the numbers are going down or they are violating the limits. For example, we can set some limits on these graphs. And if the limit is violated, then maybe the line can go to another color to make it more visible. For example, if the line is red, then I can understand that the limit is already violated. And I can set some alarms. For example, if the limit is violated, then maybe the system can send some warning to the users, to the tester, or to the developer of the product. So visualization and transforming these metrics and numbers to some monitoring graphs helps much to understand the situation. Finally, let me share you a sample application which was performed in the project focused on the bugs. We monitored lots of distribution of bugs across various parameters. For example, we monitored the distribution of bugs across the features or services in the product, or we monitored the bugs across their priority levels or severity classes, and we showed the percentage of the open bugs, closed, in progress, or rejected bugs. So we monitored the distribution of bugs across their status. So in these ways, we collected lots of insights. For example, if we observe that somehow most of the bugs in a sprint are in high severity classes, then we understood that maybe something is missing in the development lifecycle. Maybe the code review is not done in the proper way. Or when we show the distribution of bugs across the testing types, then we made some observations. For example, if we observed that most of the bugs are coming from documentation type, then we were checking if the documentation is done properly in the correct way. Or if we observe that most of the bugs are coming from performance testing types, then we were checking if the load balancers are working properly. So we made lots of different observations from the collected metrics and collected distributions, which were shown in different dashboards and graphs, and then take some action items in the relevant way. And thirdly, now we will discuss the third pillar, which is the robustness, and which is related to the stability of our executions. Because if we have some unstable test executions, if we have some instability problems in the executions, then we will face lots of false alarms and lots of failures, which are not the real failures, which are not the real bugs. Because normally it is very likely to, if the function or the feature is working properly but the test case is failing, then it means that it is not a real bug. But something is wrong, maybe about the test code, about the test execution, or about the test environment. So now let's discuss what can be the reasons for the robustness problems, why our test framework is not robust, but why we have some unstable test executions. So the most probably the reason or the root cause for the instabilities in the test executions is the test smells. Test smell can appear in automation environment, and it means that somehow if the test code or the test case is designed in a way, not in the proper way, but which can result in some consequences, then it means that we have some test smells. There can be thousands of test smells, types of test smells. There are lots of test smells defined in the literature, but we will go over some basic categories of the test smells. But at least we can categorize them in four major categories. I mean the situation of the executions in four different major categories. First of all, is if the feature is working properly and our test case reports a pass result, then it is the most ordinary situation. It is just the pass result. And in the other way around, if the feature is not working properly, and if our test case is reporting a bug, reporting a failure, then it is again the expected situation, because the feature is not working properly and our test case is catching the bug. So it is the fail case. These are the two expected conditions. But we have two not expected conditions, those are the silent horror cases and the false alarm cases. First of all, what is a silent horror? If a test case is not reporting a bug, and if the when the feature is not working properly, then it means that feature is has some problems and has some issues, but our test case does not report a failure about it. So it means we have a silent horror there. Maybe the bug will go to the production environment because we are not able to catch it in time. It is very risky. And on the other hand, we may have some false alarms, which is the failure reports coming from the test result when the feature is working properly. So it will result in some maintenance efforts and analysis efforts. Each time we have a failure report, then we will have to understand if it is a real bug or a false alarm. So they will result in really critical consequences in the project. So we should somehow minimize the test smells which can appear in automation environments and the effects of the test smell. So as I told, there are plenty of the types of test results, test smells. I will not list all of them, but I will tell you which methodology we applied in our project to solve the test smells. First of all, we listed our problems, and then we listed the test smells which can be resulting in these problems, and eventually, we found the root causes resulting in these test smells in the test automation environment. And finally, we applied some solutions. First of all, we had some analysis and rerun efforts which were blocking us to do our normal ordinary implementation tasks, because normally we are expected to implement some new features or some new test cases, new scenarios to cover the features. But if we have lots of analysis and rerun efforts, then we are not able to do the new feature implementations. So we decided to go over the root causes and the problems or the reasons for the analysis efforts. And we found out that we had some flaky tests. We have some flaky test smells in the test automation environment. And when we investigate the root cause of these test smells, we come up with a list of root causes. First of all, we had some asynchronous waits in the automation framework, and we have some undesired load and conflict situations, and we have some issues related to the suite dependency executions. And at that time, we had no track for the test history. So we went over all these root causes, and for the asynchronous waits, we applied some polling mechanisms. An asynchronous wait is a query which is sent to the APIs or to the services, but does not wait for the response properly. So when we does not wait for the response properly, then maybe we will miss the expected result. The actual result will not match to the expected result. Then it will be a flaky test. One time fail, one time pass. Maybe it may be related to the timing issues or the environment that we execute, in which we execute the test cases. So the test execution result may vary in different parameters. So but somehow if we succeed to stabilize it, I mean, if we succeed to wait for the response in the proper way, then it will be giving the same result in all different for all different parameters. For example, polling mechanism is a way to do that. If we do not get the expected result in a certain time, then we check again after some while for the expected result again, and at the end of a acceptable waiting time, then we reach to the expected response. Of course, we have some timeouts. We do not wait for the expected response forever, but for the maximum acceptable waiting time, which can be accepted by the customers, we poll for the result. And when we reach to the expected result, then we set the test result to pass. And to reduce the load in the system and to reduce the conflicts, we added a cleanup code which is developed by the help of the annotations of our test frameworks. For example, test-ng or JUnit or the other frameworks, we use the annotations, and At the end of the execution, we trigger these cleanup codes, and even in the unexpected failure cases, the cleanup code is triggered at the end of the execution, and all the objects created until that time are cleaned by the help of these cleanup mechanisms. And for the sweet dependency cases, sometimes some test cases cannot be executed with some other cases because they are conflicting with each other. So it means that we have some sweet dependency issues. The execution depends on the suite that we are running. If we put all the test cases into one suite, then it is very hard to maintain or manage. But if we divide the whole suite into some subsets, into some smaller suites, then it is much more easier to manage because we can easily or in a little time, we can analyze all the small suites and we can run all of them parallelly. It is another advantage because if we try to maintain a huge, massive suite, then it will take a lot of time to execute it. And most probably it will fail at some point. But with the help of the test groups and suites that we created, we managed them by separating them into smaller pieces. And in this way, the management was much more easier. And finally, to be able to make a comprehensive analysis, we kept the history of the test cases. Because otherwise, if we do not have any test history, and if we do not track all the history of the test case, then after an execution, we have only one result in our hands. But if we have all the history, then at that moment, we can make a comprehensive analysis at what time the test was passing and at what time it started to fail, at what time it was broken. And we can, in this way, better understand the root cause for the failure. So we kept the history in our pipelines, and we sent all the results, all the execution details to our pipelines by calling the APIs of the pipelines. And we attach all the evidences, the captured screenshots, all the logs, and each single detail and each single evidence related to the test execution. And in this way, we do not lose any evidence about the past executions as well, in addition to the most current execution. And our second major problem was the escape bugs. We had some bugs reported by the customers. Normally, we have a QA team. We had a QA team, and we are executing some test cases. So normally what we expect is to catch the bugs if there are any, but still there are some bugs reported by the customers. So how can be the reason for that? Because normally our test cases cover the requirements or the features, but still we have some bugs reported from the production environment. Then it means that maybe we are not covering all of them in the proper way. So what we did is we try to improve our coverage by applying some different test design methodologies and following some test input management methodologies. In this way, we try to improve the coverage, including the negative scenarios and all possible use cases that they are likely, which are likely to be used by the customers or the end users. And in this way, we reduced and minimized the risk of escape bugs. And finally, our third category of the problem was the refactoring effort. Very similar to the maintenance and analysis effort, we had to deal with refactoring efforts. Sometimes we had to refactor the test code because we are running an agile methodology and we are running frequent updates or change. So sometimes we have to change the test code itself. But if we have lots of duplications in the code, then we have to apply the fix into different points. But if we have only one single class or point, and then we use the single class or we call the single class from different points, then in this way we can reduce the duplication. We collect the common usages in one class or in one method and call this method or class from different instances. This is the way to reduce the duplication. And if we follow this methodology, then when a change is needed, then we apply the change or we apply the fix only on the single point of method or the class. So we managed to decrease the code duplication in the framework, and we managed to decrease different types of weaknesses in the code. We try to continuously improve the quality of the test code itself, in addition to the code of the product. And the way to do that is, of course, to perform some static code analysis methods. Of course, we had some peer review activities, and in addition to that, we made use of some tools and platforms, and we integrate them into our code development lifecycle. For example, we made use of SonarQube and SonarLand, and we integrated lots of rules. We defined lots of best practices to improve the code. And at the end of all these solutions, we were able to minimize the risks of the test mass and the effects of the test mass for critical consequences. At least for one of them, let me share the visualization of the effect of the solution by showing the before and after situation. For example, for the flaky tests, before applying the polling mechanisms, on the left-hand side, we can see that we had lots of frequent failures represented by the red bars. But after we applied the polling mechanisms, we have on the right-hand side, we can see that we had less failures, even no failures. And in this way, we reduced the flakiness in the test automation framework and the maintenance effort which is required to fix them. So from this graph, we can better understand the effect of the solution and how it contributed to the improvement of our test code. And for the quality gates, of course, as I told, we made use of some tools. And in this way, we have the strong quality gates. Because if we do not have strong quality gates, it means that we are allowing or we are letting everything or we are letting the risks go into pipelines. Because if we do not have a strong check, then maybe there are some threats or there can be some risks or vulnerabilities in the product. If we are letting them go in production environment, then maybe we will face them in later stages. Maybe not at that moment, but in maybe later stages. So somehow we have to improve our quality gates, and we should not let all the threats or risks go into the production environments. And our fourth pillar for successfully conducting an agile test automation project is, of course, the team spirit, because we are not working individually. We are working in an organization, or we are working in some different teams. Maybe it's a distributed team, or maybe a hybrid team, a compact small team. Whatever it is, we are working in an organization. So somehow we should work efficiently in harmony, because we don't have too much tolerance for inefficiencies, because we are running sprints, which are maybe 2 weeks, 3 weeks, but for sure, certainly a limited duration. So in this limited duration, we don't have too much tolerance for inefficiencies, because if we somehow do the wrong development activities, then maybe it is too late to apply the fix after some moment. So we should be aware of each other, what the other team members are doing. If they are already performing some activities, then if we try to do it again, then it's a duplication and it's a redundant work. We don't have to do it again. And if we are not aware of what others are doing, then it is very likely to do some redundant work. But with a good, after building a good communication channel, then we can work all together in harmony, because we can share the tasks or the activities within the team among members, and with a good communication channel, then maybe the development team members can inform the quality assurance team members, and in this way they can start working in the same time, because this is how we expect in agile methodologies, right? We don't have to wait for the product to be fully developed. It shouldn't be fully finished if I want to start my quality assurance activities. Whenever the design of the product is completed, I can immediately start my QA activities, just like the developers start to their development activities. Because I have already the requirements or the descriptions in the documents, so I can already start preparing the test inputs, or I can already start developing the test code in the meantime when the product is being developed. But this is possible only if I'm informed in the correct time. Because if I don't know what feature is being developed at that time, then how can I start my QA activities in the meantime, right? Because I'm not aware that the feature is being developed at that time. So these are all related to a good communication channel in the team and a good collaboration and cooperation, because we should help to each other. I mean, maybe I'm reporting some bugs or features in the bug, the vulnerabilities of the bug of the product to my development colleagues, development team colleagues. They should help me to be in the same mindset, and I should help them, because if I do not report them in the proper way, then maybe I'm not helping too much. Because if I provide all the evidences, all the scenarios, all the steps to reproduce the item, then it will make life easier for everyone. The developers can better or easier reproduce the item if I report it with a full documentation. And similarly, if they help the QA team members in the best way, then all together we will work efficiently and will remove and minimize the redundant work. Working efficiently, building a good communication channel, collaboration and cooperation, and working in a harmony is very important. And it is the only way to succeed our goals, because we are all in the same boat. If we do not embrace the quality as a motto for everyone, for all together, then most probably it will be very difficult to succeed our goals, because quality is not something that is performed by someone, but it is something that is lived by everyone. So we should all embrace the quality as a mindset, and we should be all on the same page to succeed our goals. So let's finally summarize what we discussed in this session. We went over 4 pillars for successfully conducting an agile test automation project. Those were the quality mindset, which was closely related to the customer perspective and looking to product and improving the quality from customer's perspective. And then we went through the monitoring activities, different and various metrics to continuously track for a continuous improvement in our project. And we discussed about the importance of robustness and the reasons and root causes for the instabilities in our test automation frameworks and the ways to remove them, minimize the effects of them, the effects of test smells. And finally, we discussed the importance of a team spirit. And instead of trying to perform something individually, we discussed the importance of the embracement of the quality mindset as a holistic approach. So thank you for attending, and I hope it was a useful session. If you have any questions, please do not hesitate to reach out to me, and stay safe and enjoy the rest of the conference. Thank you. Bye.